Hey, Andy here. Just finished up another blog post, similar to the one I've done in the past about installing RKE2 Rancher and Longhorn, except this one's a little different. This one is about air gapping all of the things. And I've also kind of thrown in Neuvector for fun. I will post the GitHub URL in the description, but this is the URL we're working off, very similar to the last one. And one of the things here I really wanted to kind of highlight was this shell script that I put together that kind of did a lot of the manual steps for you. And I'll kind of give you some of how I've set all this up, how I'm doing my testing, and then how I'm kind of simulating it. But the goal of this really is about using a build server to pull down all the artifacts, to compress and package up, to move across your air gap, and then install on 3 nodes. What I've done is here in my little home lab, I'm running Harvester on a single host. I can show you just real quick. I got one host. The virtual machines, I've got 3 virtual machines named AirGap 1, 2, and 3. And I actually have them here, 1, 2, and 3 in my terminal. Okay, so I sped some of this up. I did some of this ahead of time just because it takes a few minutes to do. So the first thing I did, you see here I've logged into AirGap 1. The first thing I did was pull down from version control, from GitHub. I pulled down the script. Second thing I did is after installing that installed Vim, right, is I just ran time and build. So there is a build function in the script. This will pull all of the bits for you. It'll get the Helm charts, it'll get the binaries, it'll get the RPMs. It'll even do some other fun stuff, and I'll go over that in a minute. And pull all the images themselves. And so the output really is a file, and I'll show you right now. I'll say cell and opt is this RKE2 Rancher Longhorn. We can go get the size of it, and the size of it, put a star in there, right? It's 5.8 gigs, so it's a little bit bigger than a DVD right now. And I'll have to update the docs. I said last time I ran it was like 5.3, but not a big deal. As you can see, I ran this. I ran the build function, and I ran the time around it. It took just under 10 minutes to pull everything down. And what you actually end up getting, not only do you get that ZST, but under Rancher itself, under the Rancher directory, you've got all of the stuff. You've got the script, but you've got all the stuff needed, the Helm chart, the images, even the RKE2 binary to install everything air-gapped. Okay, so in making this, one of the things I really tried to do is simplify some of the steps. And I'll go over what it does in a minute. But I've also tried to simplify the deployment. So what I'm going to do right now is, assuming you were able to pull it across that tarball, you literally could just run that air-gap script in what's called control. Okay, so let me go ahead and run that. I'll tell you exactly. We'll go over some of the things because it takes a minute to come up. So air-gap control. And what that's doing is that's still pulling a bunch of things. It's installing some of the necessary binaries. It's deploying RKE2 in a secure manner with Stig applied. Okay, so let's start with the build function real quick. What the build function does is it installs Scopio and ZSTD just to make sure it's there on your local host. Downloads the RKE2 air-gapped install files. It gets Helm, the Helm charts as well. So it adds the Helm repos, pull the charts, then pulls the images. Then I do a little magic. The upstream Rancher image list has every past version over the last couple. I don't think it's necessary for an initial install. You want just the latest. And in fact, on the top of that air-gap script, the latest is it. The versions are in there. Okay. And then it uses Scopio to copy everything down. Now on the control side, and then obviously compress. And then on the control side, right, what I'm doing is I'm adding kernel tuning. This is something I've been doing since I worked at Docker years and years and years ago. It's adding the local packages, adding the etcd user. It's updating the RKE2 configs with the Stig settings. I've got other documentation on that if you need. Setting up an audit policy, enabling Nginx TLS pass-through. So in other demos I've used Traffic. This one I'm just going to use Nginx. It's built in. That's one less thing I have to move. The other thing it's going to do is it's going to install a registry locally on the host using daemon sets. And what this is going to allow us to do is load the local registry on one machine and share it with NFS across to the other 3. And that way you have the same registry on all 3 nodes automatically up to date. There's, you update one, they're all up to date. It's literally the same back end storage. It's a neat trick I learned 6-7 years ago. Right. We're going to install and start RKE2. In fact, you can see down on the script, that's what it's running right now. We're going to set up kubectl access on that first node. It's going to start and set up NFS. Again, that's what we're going to use to share out not only the files, so you don't have to copy them to every node. We only have to copy them to that first control node. And then we're going to deploy the registry at localhost 5000. We're going to load images in and unpack Helm. Okay. This will take another minute. So again, we kind of compress these into one node just to kind of simplify the steps. But you've got your build server that builds that tarball that you move across. And then right now we're on that control plane and we are deploying that very first node. Okay. And while that is running, let's talk about some of the future steps because they'll go really quickly. So I've got another, pardon me, getting over cold. Got another function in there called deploy workers, and I can show you that in a minute. But basically, it does the same kernel tuning, adds the packages. It uses the mount point from that first node to do a lot of this stuff, rinse and repeat. So while I'm demonstrating 3 nodes, you could have 4, 5, 6, 7, 8, doesn't matter. As long as you run that mount function on all the other workers, you've shared all the files, you've shared everything needed. It'll even deploy registries, and away you go. Really kind of slick. A couple of things to highlight, right? I've added Rancher deployment, I've added Longhorn deployment, and a Neuvector deployment, okay? So TLDR, this is always the fun one. I always like putting in because, we engineers don't have time to read hours and hours and hours of documentation. Get the script, that should look familiar. I kind of ran that on that first node. Did the build function, moved the tar, control. So now we've got control running, and then in a minute, we'll basically be able to deploy worker. And then if you want, you can update the script. There's a domain variable that does the URLs. Now in this case, for this, I'm going to use awesome.sauce. But then we've got Rancher, Longhorn, Neuvector. Okay. One of the things you can do once it's done is we can validate that all of the images or most of the images are going to be coming from localhost. Keep in mind that Rancher itself, by using the air-gapped install, will preload those images into each host. So they will look like they're pulling from upstream, but they're not actually pulling, okay? And that's taking a little bit longer, so let's give that another minute. Going over the script itself, right? Here are the specific versions, and I just tested this a little while ago. It does work, so again, give that a minute. But obviously we can see the different versions, so as RKE gets updated or the Neuvector chart gets updated or you want to change the domain name for all your things, cool. Pretty easy. Everything else here is pretty straightforward. You should not need to change anything. So here's the function build. Then I have the function, that's more of the build. There's a lot of Scopio commands to pull the images. Gives you a nice little output. That's the base that does the kernel tuning. Again, I've had that for years. I'm just going to kind of make it simple, as well as setting up for some required packages on each of the nodes, as well as updating the network manager interface for Flannel. Deploy control. Here's kind of the cool thing. This little edit right here, this little echo command will actually create the STIG configs for RKE2, whether it's air-gapped or online. If you need more documentation on that, just feel free to reach out. I've got it a bunch of different places. This is the local registry. I wait 30 seconds, and then I start loading images, and you can see it's in the loading images phase right now, and it should go relatively quick. Even though there's a large number of images, but it's all local to the box. One good thing to think about, before we get too far down deep in the script, is the size of the machines. So typically I say on a 3-node cluster, 4-core, 8 gig of RAM, and an 80 gig drive. For these, I did 6-core, 10 gig. Let me see what size volumes. I think they were 80 or 100. Yeah, they're 80. They're degraded in Harvester just because I don't have 3 nodes. That's the reason why they show degraded. But as you can see below, it's working just fine. Okay, let's go back to dashboard. And in case you're curious, Harvester is running on an old Dell 630? So 2 processor, 10 core each, hyper-threaded, tons of storage, tons of memory. Okay. So there's our 3 nodes. So this is going to take another minute or two. If this gets too long, I may pause it, so just bear with me. So let's go back down here. So right now at this point, we've got to wait for that registry to fully populate is really what it comes down to. Okay, here's what I'm gonna do. I'm gonna pause the video and we'll come back in a second. Okay, we're back. Just in time too, right? So now that we've got it finished, really what it says here, it's done all the loading of the registry, everything's there, the storage is good to go. Now what it says basically, we can either go on each node and make dir and do this, or I've got this YOLO command. You only live once, right? And what this is going to do is it's going to make the local directory op rancher. It's going to mount the file system, CD into it, and then execute the air gap script. The script itself should be able to pick up variables and understand where things are from and configure everything for you. And what we can do is we can do watch. What else I got to do? Because it's set up the bash RC. Now I should be able to use, kubectl get node. All right, so there's my first node. Kubernetes is up and running fully. RKE2 fully stigged, SE Linux support, all the things, right? What we can do is we put that in a watch. Let's do something like that. So now we're watching it. We're going to do our YOLO command. So there's our YOLO for air gap number 2 and number 3. And we can see that what it's doing is it's installing all the dependencies. Let's see, this one should be a little bit further. Yep, installing all the dependencies, updating container SE Linux, and again, SE Linux is enforcing on all of these. Here, proof is in the pudding, right? Git enforce. See, we're enforcing. Let's go back to our watch command. Okay. There are a few dependencies that do need to be installed. While this is running, I'll leave that one running too. While these are running, right, we can go back and look at the script and go just kind of show you what it's doing. Oh, actually, I have the TLDR here too, right? Kernel tuning, packages, it's already mounted. It's getting the join tokens because I've actually written, when I deployed that first control node, that join token is written to the NFS share such that the other nodes, the other workers, when they come on, can pick it up and go and auto configure the RKE2 config YAML. And again, we're applying all the stigs and all of the best practices there. So let's see where that's at. Oh, cannot open RPM. I found a bug. This is a pretty easy fix. I know where it is. So what happened is I just updated. I'm going to leave this in because I think it's kind of fun just to show you. There's an SE Linux. There's an SE Linux, RKE2 SE Linux common file. So I'm going to search for 0.9. 0.9. First day with the Vim skills. So go to the end of the line. All I'm going to do is just paste in the updated version. I thought I got them all. And this will be fixed by the time you see it. Is it reading? Oh, is it? Let me fix it on the first node. Air gap all the things. Yep. 0.9. Whoop. 0.9. Go to the end. Whoop. Hate when it does that. 0.9. Go to the end of the line. Delete it. Paste in the right one. Go back. And do air worker. Cool, and that should pick up right where it is. And the nice thing is because it's on the NFS share, I can just go to this one and do the same thing. Again, that'll put me right back where I need to. See all the packages are already installed. And now it's setting up RKE2 and installing those. Perfect, exactly what we want to see. And we can go back to our watch command and we'll start seeing that populate in a minute. Okay. The reason being is because I forgot to update one of the lines. So like I said, I'm going to leave this in because I think it's fun. At least you can kind of understand the methodology of it, right? So to recap where we're at. So now it's in the process of actually doing the initial deployment. So right now you can see we're starting the RKE2 agent. And this should be relatively quick. These are pretty, the agent's supposed to be pretty quick. It's also behind the scenes when you're doing an air-gapped install of RKE2. It's unpacking. So you preload the container D with a bunch of images, and it's actually unpacking. So it does take a minute or two to come up. And all of a sudden, we'll see it. We'll get the command prompt. And the nice thing is, once this is done on the 2 worker nodes, we don't have to touch the worker nodes anymore. So we can go here and just validate that. Trying the other cool things to show you. Let me show you the script again. And at least I'll show you the rancher function, because that's kind of fun. I'll open it in the window. So there's the base function. There's the deploy control function. There's the worker function, right? So relatively, not a whole lot of steps. I'm an old school. I like Bash. You can definitely automate this in Salt or Puppet or Ansible. It's not that hard. I've got a function for a dummy app called Flask, Longhorn, Neuvector, Rancher, right? Rancher and all these, for the most part, is just doing a Helm install. I always do upgrade-i. To me, that just makes sense. But the trick is you've got to point it to use that localhost 5000 where we've deployed that registry. What that'll do is just make sure that you're always pulling the images instead of off the internet. Okay, so cool. Air gap 2 just finished. Air gap 3 finish in a sec. And notice we've already got air gap 2 kind of talking to the cluster. Come on 3, come on 3. The nice thing is 2's done. I'm gonna close the window. Don't need it open anymore. And there's 3 coming online. Cool. Now that 3's done, I'm gonna close that as well. So now everything we're doing here is coming from that first node. So the nice thing is if it's a 30 node cluster or a 3 node cluster, kind of the order of operations is the same. Once you get that first one up, you just add. You can do them all in parallel, which is really nice. So let's wait a sec for number 3 to come up. Cool, number 3's up. And let's do kube CTO get pod, and let's look at all the pods so we can see that everything's up and running. The ingress controller is coming up right now. So the ingress nginx runs as a daemon set, right? So, and again, you can also see our registry running on all 3. So what should we install first? Let's do Longhorn. Let's do it the easy way. Let's do air gap Longhorn, okay? And what this is doing is this is deploying the Helm chart, again, pointing specifically at the local registry. So what we can do is we can do a get pod, and we can notice that. And one of the functions that I put in the blog, one of the things I put in there under the TLDR is how do you validate all these things? So what we'll do is it's going to run this command just to kind of show you. Notice right now it's pulling the Longhorn from localhost 5000, and that's what we want to see. That's absolutely what we want to see. We want to make sure that it's pulling all of the necessary images from that registry. Now, mind you, that registry is on each node. It's kind of a clever trick, right? Now, in fact, kind of show you, prove it again. Because remember, we NFS mounted on all 3 nodes. If I do an LSASL under registry, if anyone's familiar with the Docker upstream distribution registry, is we can see all the different registry namespaces all within that directory, that data directory for the registry. Okay. Let's go ahead and check our pods. Longhorn's still building. We'll give that another minute. The reason why I kind of want that up because Neuvector uses that for stateful storage. So we'll deploy Neuvector in a sec. And what we can do is, we can do Rancher side by side. So let's go ahead and deploy Rancher again. I'm going to use the cheat code, right? The script /Rancher. And again, all it's doing is just doing the Helm. I'll show you right here. All it's doing is it's a cert manager install using the localhost 5000. As well as doing Rancher itself on an air gap. The cool part about this also is it's using the Helm chart in a file format. So I'm not actually serving out the Helm charts. So that's a little bit of a, I'm gonna use the term hack, but it just saves me an extra step. Ideally, if you're gonna looking at moving this to a production environment, you would want to break these things out. You want to load all the images into a separate registry like Harbor, something that's a little more enterprise, a little more maintained for multiple clusters. Same with the Helm charts, whether you store them in an NFS mount, whether you store them in a web server or store them through like Artifact Hub. There's a few others out there. I think Harbor can actually store the Helm charts as well, which is pretty cool. Okay, let's see where all our pods are. Cool, we see Longhorn up and running. We see Cert Manager up and running. And we see Rancher coming on up. Okay. Let me do this real quick just to prove to you that we've got things coming on up. What I'm going to do is I'm going to go ahead and That shouldn't be an issue. I'm going to just edit my local hosts. You can see a bunch of stuff in my home network, but what I wanted to do is do 168, 1.24. I'm going to do Longhorn dot awesome sauce, rancher dot awesome sauce, vector dot awesome learn to spell. Okay. And just to show you, that is one of the nodes, right? So I just picked air gap 3. Doesn't matter which one because we're running ingress on all 3. And so what that should allow me to do is now go to longhorn.awesome sauce. And I think Google's weird like that. I got to put HTTP in front of it. And boom, there's Longhorn, right? We can see our 3 nodes, air gap 1, 2, and 3. One of the cool things I love about Longhorn is it uses the aggregate. If you're not familiar, it uses the aggregate, so I don't have to attach additional volumes, any additional storage. It uses what's there and gives me that flexibility. And the reason why there's a lot more used on that first node is because, remember, that's where we uncompacted all of the artifacts for the air across the domain, the tarball. So that's why that's using a lot more. Okay, so we've got that. I'll leave that open just to remind me to clean that up later. Let's see where Rancher is. Rancher's still creating. That takes some, that's the old one. Sorry, there we go. It's up and running. See, it says cattle system up and running. So what we can do is now go to a new page, HTTPS. Awesome sauce. I'm using the self-signed cert. Obviously, you could use any cert you want. One of the things that you didn't see when we originally ran it, it said the bootstrap password is bootstrap all the things. So what I'll go here is bootstrap all the things, log in with local user, agree to a couple things. I always turn off anonymous statistics. Yes, that is the URL. And away we go. So now we can see our local cluster. Okay. So again, very quickly, we've air gapped all this. Within 15, 20 minutes, we've downloaded everything. We've moved it across. We've unpacked it. I had a few more minutes for spreading stuff out, fixing the bug, right? Like I said, I paused the video, but you can see air gap 1, 2, and 3. We've got our 3-node cluster up and running. And then last but definitely not least is Neuvector. So now we can do a full security suite, again, across all of these things, across the air gap on our 3-node cluster. And let's narrow this down. Neuvector. We'll let that come up. One of the other cool things that you can start to think about doing that I have not done just because I like having a little bit of separation is being able to tie Rancher into the cluster manager of Harvester so that you can schedule new clusters talking to Harvester. The nice thing about Harvester is it's just an ISO, and you literally just need a bare metal, drop an ISO on whether it's DVD or thumb drive, and kind of boot from there and be able to get a full hyper-converged infrastructure, right, to run VMs or run containers right on the bare metal pretty quickly and pretty easily. Pretty nice, right? Okay, cool. So looks like we've got the controller up, the manager's up, and we can go Neuvector.awesome sauce, and that's an HTTPS. Cool. And again, it's using a self-signed cert. And there we go. So the default login for that is admin PA22WRD. Oh, admin. So in the span of a few minutes, we've been able to fully air gap all these things, deploy them fully stigged, fully ready to go, Rancher stigged, RKE2 stigged, SE Linux enforcing, check all the security boxes. I'll show you the network activity to prove it's running on the same cluster. Give it a sec. Yes, I should change the default password. We can see Longhorn running there. We can see Cert Manager. And then actually here, what we'll do is just to even prove it again, I think I should have it as a Flask. So it's preloading the Redis Mongo Flask little simple web app into the registry. And then in a second, it'll do a deployment. I don't load it by default just because of if it's not needed, if you're not going to use it. Come on. Well, that's loading. One of the cool things I love about Neuvector is being able to understand the security risks, looking at vulnerabilities. If I can go to assets, I can go to containers, and I can see what's running. I can turn auto scanning on. When you air gap it, all the definitions come with it. So the nice thing is that we do have virus definitions for all these things. Now that it's deployed, let me look at Flask. Oh, I got to actually deploy the YAML. So let me do that real quick. I'm going to leave it as awesome sauce because, good times. In fact, what I should do here is go in here and add one more URL. So see how I've deployed all of the Flask stuff, and even my filter here with the Neuvector is already starting to see that it's coming online. It's got the containers already scheduled for a scan. I can come look at the compliance level that's coming up once it's scanned. I can look at vulnerabilities. I can look in process. I can look at resources. I can see where the image is from. Like, you can start to really drill into these things real quickly, and you can see all the different the pods that are found based on it. That kind of proves that we are deploying to the same cluster. Cool. If you've got any questions, obviously we gotta show success, kid, right? But if you've got any questions, comments, or concerns, feel free to reach out to me. You can either reach out to me on GitHub, Clemenco. There's some of my socials and my email. And I hope this was informative. I hope this helps. Let me know if there's anything I can change. Peace out.